we have the default for triple B 10 years equals 0.0324. Divide that by 10. That gives you 32.4 basis points on average per year. But your recovery is going to be 32.4 times 1 minus the recovery. And that gives you 22.68 basis points. So with the 100 basis points spread, more than adequate compensation for default risk. And then you got to say, but there are other risks besides default risk. And I don't remember what I just said before. So you got spread risk. Spreads gap out, especially in a recession, causing price risk. You have what I call correlation risk, really isn't a good term for it, but correlation risk. Corporate spreads are highly correlated to the stock market. So corporate bonds are not as good of a risk reducer as treasuries. All right, I'm kind of caught back up. Any questions up to there? All right, and then the next one.
Professor, just a quick question. For the 1 minus 0.7, where did the 0.7 come from?
Sorry, 1 minus 0.3. Thank you. So it's the 30.
Okay, thank you.
Yeah, I'm trying to catch up off the top of my head and do that backwards. Thanks. All right. Yeah, 0.3. So you got the recovery, 30% from triple B. So tail risk in an extreme case like in 2008, 09, corporate bonds can be very risky, while treasuries, yeah, and fall. And I even say fall dramatically. We're talking, in 2008, 2008, they're dropping 15, 20%, even more for the lower quality ones. Stocks, while treasuries were soaring higher. So it's not just that they're correlated to stocks, but in an extreme case, they're extremely. So the correlation gets really high in a tail risk where corporates really don't help you at all. They actually hurt you. In normal times, you got interest rates falling, so the interest rates falling offset the spread risk. So corporates do provide some diversification in normal times, just not as much as treasuries, but in an extreme time, they actually hurt you where treasuries are really helping you. And I can always forget one. I know there's one more in there. Maybe it's liquidity risk. Is that what we said? Someone remind me.
Yes, we said liquidity.
Corporates have liquidity prices, especially in a bad economic event. Well, treasuries are always very liquid. This can cause larger price risk for those selling and for all corporate investors. I'm not sure exactly how I said it last class. I probably say it different every single time, which is fine. Just put it in your own words. It's about the only essay you need for the Thursday exam. The other essays you have you're going to be doing in advance. Any questions on that? So there's your answer. I'll highlight this. I'll save it real quick so I don't lose the file this time. All right. So the second question is the big one. So here you got a $10 million portfolio. I have 3 managers. It's unlikely I'm gonna have 3 on the exam. That's a lot of calculating. I do like the idea of making you have to do the formula over and over and over and over again. It is good practice. Hopefully some of y'all worked this problem. I give you a couple of hints here. This 800,000 and this 500,000. I'm not going to give you those numbers that are going to be radically different than the answers. It could be off a little bit where I say below and slightly above or something like that. But I'm not going to say they're trying to get below 500,000 where the best you can do is 3.7 million, something like that. And I'm telling you the current level is 800. It may not be exactly 800, but it should be close. So that gives you some hints of some check digits you can use to help you with. So the question is just you just got to do the calculations, and yeah, they're intense, but you should know this formula. So first of all, you got to get the return. So you got current and A, current and B, and current and C. So here, pretty straightforward. You're going to have 70% of the current. 70% of the current is making 5.2%. And 30% is making 5%. When you do that, you should get 0.0514. Current and B is 0.7 times 0.052 plus 0.3 times, and B is expected to make 5.3 and then 5.4 for C. Hopefully y'all are checking my answers here. And for C, 0.7 times 0.052 plus 0.3 times 0.054. That gives you 0.0526. Now, did your boss say anything about the return? She does say she doesn't want the portfolio return to suffer, so that somewhat kicks out A. If you wanted to, you probably could get away with just saying kick out A here and save your calculations. Because obviously if you do A, you're gonna reduce your returns. So we could do that. Say, hey, let's strike A out here. Eliminate A due to lower returns. And that helps you quite a bit. It's 1/3 fewer of the massive formula, sorry, 1/3 fewer calculations you got to do. But B and C both are good. So let's look at risk, and I'm just going to do B and C. If you did A, that's fine. I do have the answer for A. I'll just give it to you. For A, I got, let me move it over here. Sorry, this is a crazy night. My cat's now upset. So for A, I got 0.0468. But B, I'll do the calculation for B. So remember, you're going to take 0.7 times 0.7 times the risk of A of current. Current risk is 5.4. So you square the weight and square the risk plus 0.3 times 0.3 times the risk of A. The risk of A is 7%. Plus 2 times 0.7 times 0.3 times 0.054 times 0.07 times the correlation. The correlation here is negative 0.1. Do that entire thing. Take the square root. And y'all can see if y'all get this number, I got 0.0442. Any comments on that? Can anybody confirm that?
I got the same answer for B, but wouldn't it be zero point 0.09 instead of 0.07?
Oh, it is 0.09. Okay, thanks. Good. Yeah, catch me on these. I'm kind of flustered by Bill Gates. So yeah, that's good. All right, that's all good. 442, 468. And then the same thing here, 0.7 times 0.7 times 0.054 times 0.054 plus 0.3 times 0.3. And here our risk is 0.05. Plus 2 times 0.7 times 0.3 times 0.054 times 0.05 times 0.1. Take the square root of that. And I get 0.042. So here I somewhat tricked you in that the one with the negative correlation actually had a higher risk than the one with the positive correlation because its risk was so much higher. Can anybody confirm that number? All right, I don't know if silence is a bad thing or not. Then we want to calculate the VAR. So for A, remember the VAR is the mean minus the number of standard deviations times standard deviation. So let me go ahead and do B. We're going to kind of ignore A. I'll give you the answer on A is 0.0496. Let's get our number of standard deviations. So our risk tolerance is in the question 0.75. So we're looking for the table value of 1 minus 0.0075, or we're looking for 0.9925. And if you look at the table, 0.9925 is right here, 2.43. So when we look at B, we'll take the mean with B, but the mean with B, remember, is 0.0523 minus 2.43 times the standard deviation of B, 0.0442. I get 0.0551. 0.0551 times 10 million equals 550. I'm just gonna round it. 0.551. For C, you have the expected return on C, 0.0526 minus 2.43 times the risk for C, 0.042. I get 0.0496. 0.0496 times 10 million equals obviously 496. And if you look at the current, the mean for the current is 0.052 minus 2.43 times 0.054, and that gives you 0.0792. 0.0792 times 10 gives you 0.792. Remember what she said in the problem? That their current was about 800, so that looks good. 792 is about 800, 792,000. So there's our value at risk. And she said she wanted it at or below 500. So it looks like C is the obvious answer here. Its return is higher than the current, and it's even higher than with B, and its risk gets us below that 500,000. All right. Any questions on that or any errors in my numbers? All right. And then the graph, you got to look at what the boss says. She wants you to do risk in percents. So you're going to graph 0.0, 0.052 for the current, 0.0514, 0.0523, 0.0526. If you leave, you won't have this in your case, not to worry about it, but if you were to leave one out because it doesn't make a return, then I won't count for that, but that probably won't be your issue. So you're going to do that as on the y-axis, that's your returns. And since you wanted risk, to be value risk in percent, then you're going to have 0.0792, 0.0496, 0.0551, and 0.0496. So you just graph those. I have the graph, but you'll just have to figure out the graph. So just 0.052. So set up your graph so that your range is narrow enough that you can see those points. You might draw a line across at 5.2% because you want something higher than that, and that way the 5.14 won't come up. And you might draw a graph right at 0.05, because that's the number she wants to get the VAR down to. Any questions on that? My cat doesn't have any questions, but anybody else? Everybody's good? All right, this last question, I'm probably not going to give you anything like this. It's probably going to look more like what we did. The only thing I was looking for here is the very high correlation during the crisis in 2008. And to point out that these portfolios are probably not going to help you in a crisis. They're probably going to sell off, but I'm going to give you more a traditional one. So make sure you know the formula. If I give you simulations and a risk tolerance, you have the risk tolerance, it's 0.0075. Then the simulation that equates to the VAR is going to equal the number of simulations minus the number of simulations times 0.0075 plus 1. So you're going to look at all that list. And then, so for example, it's 1 million simulations. Then you would take 1 million minus 1 million times 0.0075 plus 1. And that would equal, let me work it out on Excel real quick. And that should get you simulation 992,501. You would find that simulation, and then it really depends on the problem. But up here, we got a value at risk of 496. If I give you something like that, you want to say, hey, did I get something close to 496 in the simulation? Or is there some skewing? Remember, this up here is assuming a normal distribution. So that's part of what you're going to discuss is the parametric, which is what we're doing in A. Parametric VAR in A assumes a normal distribution, while simulation models can use more sophisticated distributions to better capture downside risk. Now, something along those lines. So let's say you do all of this and you get, I really like C. It gets me below the 500,000. And then you look at C, maybe I give you a simulation that includes C and B, and you look at it and say, wow, when you do the simulation 992,501 has a loss of 600, not 496. And B has a loss of, say, 525. So when you do a more sophisticated analysis, it looks like parametric VAR really understates the tail risk of C, and maybe that's not the right answer. It could be just the opposite. Maybe the simulation gives you 425 for C. Maybe they actually have less risk in the downside. So that's the kind of thing you're looking for. So I can't really tell you what this last C is, the one where I get a little bit more creative. It won't be anything like this, so I wouldn't overstudy the one shown here. So any questions on this? no one's saying they can confirm the numbers, but no one's saying they can't confirm them. So can anyone say all of my numbers are correct? No. All right. Well, if there's a typo, if you can't get these numbers, did y'all work the problems, hopefully? Are y'all just quiet? Are y'all not answering because you're shy?
I think I got all of them the same except for your value at risk for A.
Right, risk for A.
I got 0.0622.
Oh, you're right. I did the standard deviation. Ah, you're right. Yeah, good catch. Point. Yeah, exactly. 62. Perfect. All right. So point six.
Well,
All right. That's right. Anything else, Sebastian?
well, I had two questions. On question one, uh, at the very start when you're doing the default for BB in 10 years, that's definitely 0.0324 divided by 10.
Right. Because I gave you a 10-year period.
Okay.
Yeah.
And then for when you're calculating on the second question, when you're doing the big formula with the weighted average, where do you get the 0.09 for B?
Yeah, right here. The
Okay.
standard deviation. I,
Okay.
I, I
That's
got
it.
it wrong the first time. A is 7, and I accidentally picked up A. So B is 9 and C is 5.
Okay. Those were all my questions. Thank
I'm probably missing some. My computer has really sticky keys for some reason, and so I may have some numbers up. All right, anything else? So I will put this out on YouTube on our channel. Everything in yellow is what you calculate. Everything else is given to you. I didn't give you the graph, but I will put the graph, I will put my Excel graph into the Word before I send it over so you can at least see it. All right. I think that's it. So I'll see y'all Thursday. The exam's at 5 o'clock. Don't come at 7:30. I had a student come at class time in one of my other finals. The final starts at 5 o'clock in our classroom. Any questions on the essays at all? All right. So we're done. I'll stay on a couple minutes in case a shy person has a question, but we're done. So I'll see y'all on Thursday then. Thanks a lot.
Thank you, Professor Sweet.
you. Professor,
Uh-huh.
for the essays, and I know you tell us not to like ask you this, but I mean, for the questions, like how in depth are you expecting us to go? Like, is it like something I could write from what I remembered from the class, or is it like an in-depth
It's
discussion
much
on?
more of that. It's open book, so I'm expecting more with it being open book. If you're not sure,
Okay.
put one in there. We talked quite a bit. So yeah, um, the probably the one that needs the most depth is the diversification one. The example answers I've seen have been really strong. They've been several pages. So yeah, there's definitely students putting quite a bit into it. It's not like it'd kill you if you're not in depth, but it can. There's some obvious things that it should definitely be in your answers. So definitely use the rubric on the second question.